On example 4, we're going to be seeing problems that involve the rate of work done. And that is how we are going to be expressing this. This is in the rate at which a job is being done. So for an application problem involving work rates, you want to think of the rate as being calculated by number of jobs a person can do over the amount of time it takes. Number of jobs over the amount of time it takes. That's kind of the key, the guideline to follow when setting up these work rate problems. On our example, it says Marta can vacuum the house in 40 minutes. She can do that one job in 40 minutes. It takes her daughter 1 hour to vacuum the house. So her daughter can do the one job so that our units jive, let's, instead of saying 1 hour, let's write this one in terms of minutes as well. So 60 minutes. How long would it take them if they both had their own vacuum cleaner and they worked together to vacuum the house? Okay? So we're going to express the rate of Marta. She can vacuum one house in 40 minutes. If she's working together with her daughter's rate is she can vacuum the one house in 60 minutes. And so when they work together, they're going to be able to vacuum the one house in X minutes. So let's remind ourselves that X is the number of minutes that it takes to vacuum the house when both work together. I'll just write number of minutes of both of them working together, or for both. We should probably say for both of those working together. Now, in this case, we have a rational equation. And so one thing that we consider when solving a rational equation is we have to exclude from our solution set any value of x that would give us 0 in the denominator. We would probably toss an answer of 0 out for our application problem anyway, just because it doesn't make sense. It's not like if they work together, the house is going to immediately vacuum itself, although that would be awesome. Then the next thing we need to consider on these is clearing out the fractions. What's the least common multiple amongst the denominators? We need a quantity that will cancel out 40, 60, and x. So for the 40 and the 60, I believe 120 will work, and then we also have to have an x to cancel that out. So there's our least common denominator we're going to multiply through to all three terms. So times 120x here, times 120x here, and times 120x here. Now, when we reduce, 40 will go into 40 one time, and 120 3 times. So we have 3x plus, reducing here, 60 will go into 60 once, and 122 times. So we have remaining 1 times 2 times x, or 2x, equals, here the x is reduced, 1 times 120 is 120. Solving this for x, 3x plus 2x is 5x. Divide both sides by 5 to solve for x, and the number of minutes it's going to take when they work together is 120 divided by 5, which is 24 minutes.